Okay, ladies and gentlemen, here we are again. So as promised, I'm going to talk about the difference between nominal and real interest rates. Because people have a bit of trouble with this, and this is our first introduction to using mathematics in a theoretical setting. Here, it's not really a theory. Here, we are defining what we mean by the interest rate. We're defining what we mean by the real interest rate. So, one other thing I should mention is that a couple of people have been having trouble accessing the videos. Apparently, there's password protection. I will sort that out today. And hopefully we'll have a decent video of this in case you need to go back to it. Okay. Okay, so our first question is, what is the interest rate? And our second question is how to keep me in frame. That would be nice if like the video turned out. Right, yeah, that would be good. Okay. That's better. That's better. All right. So what is the interest rate? Well, the interest rate is if I loan you money. So I loan you say K euros, 100 euros, 500 euros, 100 million euros, whichever, right? I loan you some number of euros. So then we wonder, how much do I get back at the end, right? So then, so after 1 year, say, after 1 year, I get K back, plus I get the interest on K, which is equal to K times 1 plus the interest. Little I for the nominal interest rate. And this is really the definition of the nominal interest rate. It's, it sounds like it's have to memorize the formula, but this is actually, what the interest rate is. It's how much more do I get paid back at the end for each euro that I loan, right? Okay, simple. So I loan 1 euro. The interest rate is how much more do I get paid back? I get paid back by 1, plus I get paid back some amount extra. That's the nominal interest rate. Okay. Now, the real interest rate is the same thing, except in terms of stuff. So if I loan you a trolley full of goods, at the end of the year, how many trolleys full of goods do you have to pay me back? Okay. So this is, here we have the definition. Of I, the nominal interest rate. Okay, and now we want to think about the real interest rate. Okay, real interest rate. I loan you 1 basket of goods. Goods. How many baskets do I get back at the end? My poor little computer is totally overwhelmed. I see it writing like 10 minutes after I write. It's very disconcerting. All right, so how many baskets of goods do I get back at the end? Right. And so we know that the consumer price index is a measure of the cost of a basket of goods, right? So that's called the CPI T equal the PT, the price of a basket in time T. Right. And then we'll have PT plus 1 is the price of a basket 1 year from now. And so we're wondering, would we loan this basket? How much do we get back at the end? Right? And now we have a price of a basket, because in real life, we can't loan a basket of goods. But what we can do is we can take that basket of goods, notionally sell it, use that to buy euros, right? You sell it, get euros, invest the euros, not invest, loan the euros to somebody, and then when we get the money back, convert it back into stuff, use the money to buy stuff. And so it's kind of convoluted. We have a number of stages. Take your stuff, sell it, use the money to loan to somebody, and then take the money that they pay you back, convert it back into stuff. And we wonder how much stuff do we get, right? Okay. So 1 plus the real interest rate equals what? Well, first thing we need to do is we need to sell our stuff, right? We got one basket of goods, one trolley full of goods. We need to sell it. How much do we get for it? Well, we get however much that stuff is worth. Right here, where you convert just converting goods to euros, selling it. If you have 100 things and you sell them at 5 euros each, you have 500 euros. Yeah, you get the number of things that you sold times the price of the thing. Here we're selling one thing, one trolley worth of goods, everything in the consumer price index, we're selling it, and we get that amount of money. Right? Now we've got euros, now we can loan the euros to somebody in the economy that we live in. So at the end of the year, 1 plus I, and if we think about this whole bit here, this is number of euros at the end of the year. All right, so we took our trolley of goods, we sold it, we got the price, that's how many euros we've got, and then we loan it to somebody. At the end of the year, they pay us back the amount that we loaned them, times plus the interest times the amount that they owe. There's a 5% interest rate. They pay us 1.05 times the amount that we loaned them. Right? We get back our principal plus we get our interest. But now we've got it in euros. Right? We don't have it in terms of stuff. So now we got to convert it back into stuff, because we're wondering if we loan enough to buy, if we loan one trolley worth of goods at the end of the year, how many trolleys worth of goods do we have? Right? And so we need to find out how many trolleys we can buy with this. And if you have 100 euros and you're buying Snickers bars at 2 euros each, the price is 2. You're starting out with 100 euros. You take your 100 euros, you divide it by the price. That gives you the number of Snickers bars you've got. Right? So you'd have 100 divided by 2. You'd have 50 Snickers bars. Simple. Right? And we're going to do exactly the same thing. We have all this money, got all this euros, and we're wondering, we want to buy a bunch of trolleys worth of goods, so we have to divide by the price. Right? And so we have one. That was a mistake. Let's do that again. Erase that, do it in black. 1 over PT plus 1. And this is use our euros to buy goods. So this whole thing is the number of goods at the end of the year. So we said that the real interest rate is we take a trolley worth of goods, we finagle it, we loan it out, we convert it back into goods, and we're wondering, we give up a trolley worth of goods today because we loaned it out. How many trolleys worth of goods do we have at the end of the year? And that is just calculating how you did that. Right? This is all it is. Okay. Okay, so this is really the definition of the real interest rate, right? It's not like I've done anything clever. I said the real interest rate is this, and now I just converted that into math. And that's one of the things we're going to be doing a lot in economics, particularly the theory side. Is we have three ways. We have three ways to think about any sandwich. That's true, but we also have three ways to think about any theory, any explanation we have of the world. We have an intuitive way, we have a graphical way, and we've got a mathematical way. And all three of those should be telling you the same thing, right? You have some intuition about how the world works, right? You turn it into graphs to try to understand it, and you turn it into math to force yourself to think very, very logically about it, right? So now we have what the real interest rate is. This is the definition of the real interest rate. And now we can think very, very logically about it, right? Because the beauty of math is once you've got it down into a mathematical equation, any legal mathematical thing you do is, first of all, very logical, very bad grammar is what it is very, very bad grammar and very logical, and anything you do is consistent with that. So you can use all the power and glory of algebra and mathematics to try to learn something about it once you've put it in mathematical form, and every single thing you do is thinking logically about it. So it's a way to force yourself not to let anything slide and to be entirely consistent with your story. So here we have the definition of the real interest rate, but we said it had something to do with inflation, right? We said the real interest rate had something to do with the nominal interest rate and inflation. And here I've got the nominal interest rate, but I don't really have inflation. I got prices. I got prices today, PT, and I got prices tomorrow when I'm selling my goods, PT plus 1. And clearly that's related to inflation, but it's not inflation itself. So we want to convert this to try to think, is there a relationship between the real interest rate, the nominal interest rate, and inflation, right? That's where we're going. So, we're not going to be, we're going to be doing some manipulation, but we're doing manipulation for a goal. It's not just like, let's play around with it, which we can do. Like we're perfectly fine. As long as we do any legal mathematical thing, we're good to go. But, here we want to see how it's related to inflation, right? So I want to take these prices and convert them into inflation in this equation. Okay, so our next page, we have our 1 plus R is equal to PT over PT plus 1 times 1 plus the interest rate. Okay, the nominal interest rate is something that you can see when you go to the bank. If you ask for a loan, the nominal interest rate is what they're going to charge you. If they post it on things, it's required by the financial regulator to be displayed to you. So that's a thing that you've got at your fingertips, right? But today's prices, we know. Tomorrow's prices may be less so. And the real interest rate is a notional thing. It's not something that you'll ever see posted anywhere because it's not something that anyone can know, because we don't know the prices in the future, right? But it's something that we can calculate after the fact. It's something that we can think that people are thinking about, even if they can't, see it, thinking, what is this real interest rate going to be when they're making their decisions? Okay. Now, before, we were told that the real interest rate is equal to the nominal interest rate minus the inflation rate. Well, we weren't told that. Sorry, we were told that it is roughly equal. It is not going to be exactly equal to that, but it's close enough for government work. Yeah, for most governments, not all governments, but for most governments, it's close enough. And so we're going to be looking for an approximation. And I'm going to have two ways that you can do the approximation. You have the easy way and the hard way. Both of them are exactly the same. The easy way involves natural logarithms. If you know and love natural logarithms, then you don't have to learn the other way at all, because you can do the easy way. If you don't know and love natural logarithms, you should expect to see some natural logarithms in your life coming in the next few years. So it'd be well to get comfortable with them, because in empirical work, they show up all the time. In theory, they show up all the time. They show up in empirical work because natural logarithms are closely related to growth rates, which we'll see in a little bit. And so growth rates are clearly something we care about. What's the growth rate of population? What's the growth rate of GDP? What's the growth rate of technology? All these things are things that we care about. And so it's very easy to express that in logarithms. We very often think that, for example, our policy is going to affect the growth rate of something, right? And so we would want to express our something in terms of growth rate and then look at in terms of our policy. So we would very often use natural logarithms. In theory, we use natural logarithms a lot because they make the complicated easy. They make things, lots of things, not everything, but lots of things linear that by nature aren't. So let's start. We're going to have two approximations. Here we'll start with approximation 1. Okay. So I have this equation. 1 plus r is equal blah, 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 blah. It's just an equation. Right now, we're done with our story, and now we can just think of it in terms of math. And any legal math thing that we do is going to give us completely logical results. So I can do any mathematical thing that I like to both sides of this equation. It's not, it's completely up to me. I can take the cube root of both sides. I can cube both sides. I can take the natural logarithm. I can take both sides to the exp. I can divide both sides by 7. I can't divide both sides by 0 because that's not a legal mathematical thing. But any legal mathematical thing, I'm good to go, right? And so the thing that I am going to do is I'm going to take the natural logarithm of both sides, okay? As is my prerogative. So I get ln 1 plus r is equal to ln pt over pt plus 1 plus I, like so. That's perfectly fine. I can do that. You can say, why did you want to? Well, it doesn't matter why I want to do. I just can't. Well, it matters, obviously. What I'm trying to do is I'm trying to get, in terms of growth rates, natural logarithms are closely associated with growth rates, right? And the inflation rate is the growth rate in prices, right? And so I know the inflation rate is the growth rate in prices, so the natural logarithm is sort of a nice, neat, clean way to get that. Okay. So what does this give me? This gives me ln 1 plus r, r. And a nice feature of natural logarithms is that when you have things that are multiplied by each other, the natural logarithm becomes additive, right? If you have a times b, the natural logarithm of a times b is the natural logarithm of a plus the natural logarithm of b. And if things are divided, it's just subtracted. So the right-hand side becomes ln pt, minus ln pt plus 1 plus ln 1 plus I. Okay, and this is perfectly fine. This is a thing that we can do. Right? Right. Here, I have a pointy stick or something. Yes, I have a pointy stick. So my laser pointer isn't working today for some reason. So get pointy stick, old school. We're going old school today. Right. So here we've got this divided by that. So it gets ln pt minus ln pt plus 1, reflecting the division. And this whole bit is multiplied by 1 plus I. So it's plus ln 1 plus I, like so. Okay. Let me carry this to the next page. We have ln 1 plus r equals ln pt minus ln pt plus 1 plus I. And now that's equal to minus ln pt plus 1 minus ln pt plus ln 1 plus I, like so, just noticing that I can't, my pointing stick isn't long enough. It's so sad. Yeah, just taking those things together. And I'm taking those things together because this thing here is the percentage change in prices. Prices, which is just the inflation rate. So you see what this taking ln has done for us, and this is typical, is two things. One, we're interested in a growth rate. The difference in the natural logarithm of things is the percentage change. So we got the percentage change in prices. That's the inflation rate. It just pops out. We're good to go. The other thing it does for us from a theoretical point of view, which is really handy, is it makes this nonlinear thing linear. Right? It used to be we had price divided by other price times 1 plus I. It was a nonlinear thing. But if it's just a multiplicative and divided thing, when you take the natural logarithm, everything becomes linear. And lots of times we can solve stuff that's linear, but maybe we can't solve it so easy if it's not linear. And so we lots of times take natural logarithms just to make things linear so that it's easy for us and our tiny brains to deal with. Okay, so what does this give us? This gives us ln 1 plus r is equal to ln 1 plus I minus the rate of inflation. And this is exact. So we're all good to go here. We haven't made any approximation. So clearly we're told that we had this relationship between the real interest rate and the nominal interest rate and inflation, and it was approximate, but we don't have anything approximate here yet. So what's up with that? Well, here's the deal. We got ln 1 plus r, we got ln 1 plus I, and my r is sad and lonely there. Okay, yeah, that did not help. Like so. Here is another feature of natural logarithms. And this is a side fact. ln of 1 plus x is approximately equal to x if x is small. Okay. So the natural logarithm, if we have x here, we have ln x here. If x is equal to 1, we make that 1, it's 0, like so, and it looks like it's negative here, and like that. And the slope at this point is 1, it's 45 degrees. And so if we make small changes from 1, a little bit higher than 1 or a little bit lower than 1, 1 plus x, then the slope is 1. And so if we add a little bit, we're going to get the same amount back in the logarithm. Okay? This is just the fact of how it's constructed. It's a concave thing, and it has a 45-degree angle right here. And so if we make very small changes around 1, adding a little bit more in this case, our x, or a little bit less, our result is going to be very, very close to x itself. If we add 0.05, it's going to be almost 0.05 higher. Right? Now it is curved, and so if we add a very large amount, it's not going to be that. Right? It's not going to stay on that 45-degree line. If we sort of put in a 45-degree line here, it looks like this. Right, 45 degrees. So for large x, this is not true. But for small x, it's very, very, very close to true. And so what we get is we get r is almost equal to interest rate minus the rate of inflation. So we go back. We have ln 1 plus r. So if we think of this r as x and it's very small, this is going to be almost equal to r itself. And over here, we got ln 1 plus I. We think of I as very small. 0.05 would be like a normal amount for the nominal interest rate. They're talking these days, we're going to raise our nominal interest rate up to 4%. So that's small for this purpose, right? And so this is going to be approximately equal to I, and then inflation is just inflation. Okay? And that gives us our approximation, a relationship between the real interest rate and the nominal interest rate. Okay. Approximation 2. We have 1 plus r is equal to pt over pt plus 1 plus I. And this time we don't want to use natural logarithms because we have a phobia. It's an allergy. I know a lot of you have been traumatized by evil uses of math in your past, and so you have issues with it, PTSD from high school math. But you're going to have to come to grips with some of it. Now I don't know. I want to be nice and encourage. I do understand that some people have been badly abused by high school teachers, math-wise. I would ask you to try it fresh. We have, by the way, economics drop-in center. If any of this is scary to you, like some of you look bored, and some of you look like, what the fuck, and I don't want to even pay attention to that. And a few people in between, but by and large, I got the two crowds, right? If you're in the what the fuck category, take this stuff into the Economics Resource Center. Like this is a really good time to start fresh with this stuff. You don't have to learn all the math in the known world. We're going to be doing the same kind of things over and over and over again in terms of mathematics. It's not super hard math, but it is kind of everywhere. And so, like the things you saw, plus these LNs and a few other little things that we use all the time. Like if you can get that stuff down, there'll be a few more things along the way, but if you're solid with that and comfortable with that in this context, you'll go through it with relative ease. But if every time you see an equation you freak out inside, this is going to be a problem for you because they're not hard, but there are loads of them. They're everywhere. And so if any of this is if you're a bit rusty, that's fine. But if you feel the freak out in your soul, and I do understand that some people are like that, what you want to do is you want to start fresh and you want to deal with it now because there will be more, right? And so if that's you, and you are not alone, if that's you, it's not exam period yet, so this is a really good time to deal with sort of these fundamental building block things. This week, go into the Economics Resource Center and ask for help, because it's not something that you go in one day and it's done, right? It's learning. Learning is always hard. Learning always takes time. And so if you start now, you'll be good. And if you don't, it'll be harder for you, right? If it's easy, great, don't mess with it. But if you're having troubles, please take a look, because this class, it's going to be a bit of it. But as we go forward to next year, there'll be more and more, and dealing with it now makes your life so much easier, right? Okay, so here we are. We have this approximation. We want to get it in terms of inflation. And so we have inflation, which is the percentage change in price. So PT plus 1 minus PT over PT. That's the definition of inflation, the percentage change in prices. And so we need to convert our equation on the left into get those prices to look more like inflation, right? This is our thing. Okay, so what am I going to do? Well, on the right-hand side, we got all this mess with the 1 plus I, which is going to screw us up. And so I'm going to divide both sides of this equation by 1 plus I, just to get the prices separate. No other reason, just to get them separate. So I get 1 plus R over 1 plus I is equal to PT over PT plus 1. Just divided both sides by 1 plus I. Okay? Anything I do to both sides is fine. And this is fine as long as the interest rate isn't minus 100%. And for most economies, most of the time, it's not minus 100%. Normally, it's like 0.05 or 0.06 or 0.02. In some economies that have very high inflation, you can have 100% interest rates or 200% interest rates. So it might be 2 or 1, but it's very rarely negative, and it's certainly not negative 1, right? It might be negative 0.02, but it wouldn't be negative 1 in reality. So I can do this because I'm reasonably confident that the interest rate isn't negative 1. Okay. And just as we're doing the math, you have to check and make sure what you're doing is legal math stuff. Like we can do anything we want to both sides, but we have to do legal stuff to both sides. And so that's just checking. Okay. Okay. Now what I'm going to do is I am going to flip both sides over. So I get 1 plus I over 1 plus R is equal to PT plus 1 over PT. And to do this, I have to be reasonably confident that 1 plus R is not negative. I mean, it's not 0, right? So R can't be negative 1, but that's even less likely because generally we have inflation as well. So we're probably good there. Okay. Okay. Why did I do that? And this is important. Like, keep in mind why I'm doing this is because look, in my inflation, I want to write things in terms of inflation, and I have PT in the bottom. But in the middle here, I started with PT on top. Now, so I didn't like that. I want to get my PTs on the bottom so I can get it in terms of inflation, right? So I flipped it over so that I can get things looking like that inflation equation up there, because that's where I'm going. We're trying to write this equation in terms of inflation, and so I want my PT on the bottom. Okay. All right. So I did that, and now we got the PT. Well, I can't. And we got the PT plus 1 over PT. That's nice, but I don't have the minus PT over PT. So what I'm going to do is I'm going to add and subtract that. So I'm going to subtract PT over PT, and I'm going to add PT over PT. So what I've done is I've added 0 to both sides, right? I'm sorry, I've added 0 to both sides, just add 0 on the left, and here I'm writing my 0 in this particular way, minus something plus the same thing. Okay. So I can do that. It's a goofy weirdness, but you know, no stopping me now. I can just do any weird mathematical thing I want, and that's the one I want. And why did I do that? Well, I'm trying to get it to look like inflation. So on inflation, I got PT plus 1 minus PT all over PT. Here, I just had the PT plus 1 bit. So I wanted to get the minus PT bit as well, because then this thing here is just going to be inflation. So this is going to be equal to inflation plus PT over PT plus 1. Or 1 plus I over 1 plus R is equal to inflation plus 1, right? Because we go back, that's not right, because I wrote it wrong. People stop me when I do dumb things. Please. So my dissertation advisor said, I got 2 pieces of advice for you. One is talk low, talk slow, don't say too much. And the second one is never do algebra in public. So, you see why. And in fact, he was wrong about it. It was not complete advice. That was very good advice. Complete advice is never do algebra in public alone. that you want someone watching me because, so please, like when I do dumb algebra errors, please stop me because, yeah, I will do as will everybody, right? It's the nature of things. Okay. So there we go. And so now we're getting somewhere. So let me multiply both sides by 1 plus r. So I get 1 plus I is equal to 1 plus r times 1 plus inflation for what it's worth, which is not what I'm going for. Remember, what I'm going for is r approximately equal to I minus the rate of inflation. So that's not it. Okay. So let me multiply out the right-hand side. 1 plus I is equal to 1 times 1 is 1. 1 times pi, inflation is inflation. R times 1, R pi. That's just multiplying out that polynomial. All right, we got 1 times 1, 1 times inflation. That's this bit. R times 1, that's this. R times inflation, that's that. Okay. Now I've got 1 on both sides, so I can subtract 1 from both sides, and I get the interest rate is equal to R. Well, let me write it the same way. Pi plus R pi. And then I want it in terms of R, so I have I minus pi minus R pi is equal to R. Okay. And this is exact. This is an exact thing. Right? We didn't make any approximations anywhere. We just did the thing. Right? We manipulated it, wrote it in terms of inflation. Now we're good. We got our thing. Except it's not the thing we started with. Right? It's not where we're going. Because we got this R pi bit. Right? But if we think about what the real interest rate and the nominal interest rate are, the nominal interest rate, the inflation rate is probably something like 0.05. The real interest rate's probably something like 0.03. So 0.05 times 0.03, really, really small, right? 0.00 something, something. So very, very small. If R pi is small, then R is approximately equal to I minus pi. And there you go. That's where we're on. So what can we say about this? Well, first of all, this gives you, like, really, what the heck is this real interest rate he talks about? This is it. This is the definition of it. We've manipulated it. This is what there actually is. There's no deep science behind it. It's a definition, and we've manipulated it to write it in terms of things that we know and love and care about. This inflation rate is something that you see posted all over the place. The nominal interest rate is something that you can see posted at the bank. So these are things that are easily measured, always issues with measurement, but easily measured, easily observed on a daily basis. You can go to the Financial Times and find out the inflation rate and the nominal interest rate in a moment, and you can calculate more or less what the real interest rate is. So easy, quick, nice, just based on what the real interest rate is. And again, we care about the real interest rate because it's going to turn out business people buying homes, this is going to be what they care about when they make their decisions. We care about the nominal interest rate and inflation rate because these are things that our policymakers might be able to manipulate. Okay? It's going to be a bit of a trouble because when we make the nominal interest rate high, we're also going to tend to make inflation high, so they can balance each other out. But these are things that we might be able to play around with. And so if we can play around with the right-hand side, we're going to influence the left-hand side, which is the thing that people are using when they're making their decisions on whether to invest or not. So that's why we're going to care. Okay. The other thing to say is that lots and lots of people learn and they tattoo this on their arm and they know that the real interest rate is equal to the nominal interest rate minus the rate of inflation. And they pretend like they understand that and they go off to London and they make a ton of money, tons of money. It's just rolling in investment banking and hedge funds and all of that stuff. This is something that comes up a lot. Like this is everywhere. So lovely, they make a ton of money. And then they get moved to the developing country desk. And they get moved to the developing country desks, and all of a sudden, everything falls apart and all the money disappears. Why? Because it's a very good approximation for most developed countries most of the time, right? Because our inflation rates are low. So we can think about this inflation rate as being 0.1 or less, 10% inflation or less. It's 7-ish percentage now, 7, 8, depending on whose numbers you use, but it's, it's 0.08, 0.07, this is something like that. And the interest rate is like 4%, 0.04. And so these numbers are really, truly very small. And so, yeah, the approximation is really, really good, right? On the other hand, you go to Turkey, where they're working with 100% inflation these days. So pi is 1, and I is say 1.1. Right, 110% interest rate, then, okay, you say it's 0.1, but now this R times pi is not so small, right? It's 1 times 1.0, 1.1. The whole thing is 1.1. It's a substantial number. And so the approximation is not good when you have large interest rates or when you have large inflation rates, okay? Which is just, why it's nice not to memorize the thing, but to understand where it comes from. Any questions about this? Okay. Hopefully the video of this turns out, and I'll make a decent video of this so that people can go back over it, and I'll put the slides up and all that. Are people leaving? What time is it? Did I talk that long? Oh my God. What the heck? Oh. Yeah, I did. Oh man, I went on. Okay, I'll let you go, and I will see you next time.